Welcome to Bungalows for Bachelors. Tall walls. What are they? What does it mean? Well, the short story is walls that are taller than 12 feet. This might vary in some different jurisdictions, but the general consensus is that 12 feet, because 12 feet is pretty much when the general rules of the IRC and things like that tend to, pre-cut stud length, they usually go up to 12-foot lengths. And, well, they can go up to 12-foot lengths. And when you start to get and build walls that are taller than that outside that category, you're going to generally start to need to look at special design considerations, how to specially build those particular walls so that they don't have problems. So, what does that mean? Why would they have problems? Well, there's a few things that are happening here. So, remember the conversation we had about column stability, right? If I put a weight on a column, it's going to want to buckle, especially if it's super tall and slender. That's the word that's used. So, it's a really tall one, right? So, when I build a wall, the wall is built out of top plates and bottom plates and studs. So using them, generally speaking, 2x4s and 2x6s. When I start to make very tall walls, then I get what looks like this. And I get very tall, slender studs. Now, what where you want to make sure is happening in two ways is if I'm looking at the studs like this, the first thing I don't want is I don't want the studs to be doing this, right? I don't want them to buckle this way. But if I were to turn and look at the wall from this side, and I were to look at the wall like an assembly, for example, there's the bottom plate, cross section, a stud, and then top plate, and then another top plate, right? So I'm looking at the wall as a cross section. I also don't want the studs to blow. I say blow. The wind will blow on a wall that's tall and push the studs inward. I don't want too much of that, because if I get too much of that, I'm going to stretch the sheetrock and stuff, and going to crack things and break things, and it's bad. We don't want it. And if you got stucco on the front, it's going to crack that and break it too. Crack and break stucco on the front. So bad stuff. So when wind blows on a wall inward, it's going to deflect inward. And we also don't want it to do this case either. So we usually look at tall walls in a special way to make sure that those things are not the case. And if we need to do bigger studs, like 2x8 studs maybe, or we just need to take our 2x6 studs and put them closer together, then that's what we do. But that is something that we have to check out. So whenever we have a wall that's taller than 12 feet, any part of the wall, then we have to look at it. Now, the other thing we'll do when you get to really tall walls is, because of this wind blowing in factor, we kind of have to treat all the other parts of a wall assembly a little bit differently too. So for example, I have a really tall wall and I've got some studs. So the general principle of what's happening here is each one of these studs is serving as the thing that is keeping this bowing in from happening right here. It's keeping that from happening, right? So if I put a window in this wall and I have something that looks like now this, so the stud will continue on the bottom and on the top. So I put a window in my wall. Well, what I did here is I displaced one of the studs, and of course, because I did that, I need a piece here. Because I did that, I need a header, right? I need a header above my window. So that takes care of the gravity part. So the load coming down will be taken to the header, sent out to the studs. That's all fine. However, I also need to consider, what did I do to the wind load part of the wall? What did I do to this part? Well, what I did was this. Let me change colors here. This stud is collecting a bunch of wind load, right? It's got a tributary area that it's responsible for on the wall face that's something like this. It's catching that area of wind, right? And that load is pushing the wall inward. And the place where that's caught is right here. So if I'm taking all that load and I'm putting it on this short little guy right here, and that's just, in a gravity situation, that's not a structural member. That's just there to, shape out the window and be something to attach to. But in a wind loading situation, that guy is actually serving as a small little beam, a small little, load bearing member, if you will, because its job is to carry that wind load out to the other full height studs that have full support from the bottom all the way to the top. It's carrying that wind load out to these guys, because those guys are going to do the work of holding it. So in that situation, what we might end up needing to do is, if we have a big enough window and we displace enough studs, sometimes we might double the sill. We might put two there. It looks like one, but let's draw it in thick board things. So there's two, right? We put two there, and usually anytime we displace tall wall studs, we're going to double up the king stud on the outside. So we're going to put two of them there. So we are making sure that this whole assembly is very rigid when it comes to wind loading. So don't need it in terms of gravity, but we sure do need it in terms of the wind stiffness, not making the wall buckle inwards like this. So there's funky, complicated things to deal with when it comes to a tall wall, and we will deal with some of those in some of the future example designs that we do because there are some stairway tall walls that are created, and we will get to it at that time. But just introducing you to the tall wall concept.